In a previous video I said that probably you wouldn't need to remove the front cover from the tray. However, turned out that the main board couldn't be pulled out to the back. I did unscrew all the cable, I took off all the cables, I took off the screws, but it was impossible to move or wriggle the board out of the box with the front face because of a shape here, a U shape that the main board has that touches a plastic ribbon, a reinforcement ribbon like this one over here. So that was causing that it was impossible to get out the board. Also, you have to think that it has these front plugs, plugs, potentiometers for volume, bias, etc. So at the end, I faced myself having to remove the front cover completely so that I could take the board, not exactly to the front, but at least to be able to lift it from a side and out, or otherwise probably you wouldn't have been able to pull it out to the front either, because it would have again hit this reinforcement ribbon. So actually the only way to take it out is actually lifting this side first and then whoop, that away. More things that I could say. Well, the project is now finished. You will see that I still have some markings in this sort of battery capacitor. This is for memory functions. But well, it's I'm gonna leave it there. I don't think that the memory functions are that important anymore. So probably that battery will, I will stretch the life. I didn't find a battery of similar capacitance anymore. There are higher capacitance, 10. However, yeah, like I said, I didn't want to change because I was using the AI to check if a higher capacitor battery could be a problem, and yes, apparently in some circuits it could be an issue, so I decided to leave it as it is. More things that I could mention of this board. Yeah, actually this is an interesting board to learn a little bit. So as you see, there is here a Dolby chip. And there are some bipolars here, bipolar capacitors there, and bipolars over here. Shouldn't surprise you, because in a cassette deck you are recording and playback. So actually, I was a bit surprised at first why I was finding bipolar capacitors in a device of this class. I didn't expect complex circuits, but then I realized the same Dolby chip does the encoding as decoding. It's not two separate chips, but one, the same chip. So that means that the bipolar are carrying the signal, and that's why they are bipolar, because sometimes the signal will be going out the deck, sometimes the signal will be going in, because it's during recording that it is encoding. So that made me think that probably most of the capacitors near the Dolby chip will be audio, but I didn't have 0.1 microfarad of audio quality. I only had these automotive ones because they have become very hard to find. So I was checking on in the artificial intelligence if it was telling me a little bit what was the purpose of this 0.1 microfarad. Turns out that it has to do more with timing. So apparently it's not carrying the signal to the chip, but timing the chip for the encoding and decoding. So at the end I decided to put the automotive and don't spend more time trying to find audio quality. The rest I've put Panasonic, general purpose. Here you have two capacitors, probably for the phono out. There is an op amp, so I'm guessing that these are for audio. Might be carrying the signal, maybe not. Maybe they are just to stabilize the current for the op amp. Then here a couple of other general purpose. What else? Well, this is clearly an audio section with that op amp there in the middle, so I've replaced them all with audio quality capacitors over there. This area is clearly a power section, so all of these are Chemicon capacitors for power supplies. all of them, YK series in different letters, because you have taller, thinner and taller series. You have other series that focus on being very low height. So it's a bit of a mix of capacitors, but all from Chemicom, from the same quality, 10,000 hour capacitors. It's just that they are slightly different in the series, whether they are taller or lower height models. And I think that that's about it. You will have to take off a lot of grounding cables. Look here, grounding over here, grounding over here. Without taking them off, you won't be able to take the main board. And I was also unable to unplug the tulip connector board. So what I decided is to unscrew it, and I took the board together with the main board, and I've been doing the last bit of soldering. Because what was the reason that I took the main board out of this cassette deck? Remember that there is a plate underneath that allows you to replace most of the capacitors. I only had problem with capacitors very close to the transport. They were I wasn't able with the soldering iron to remove the tin from them, so I needed to no, actually I did at the end. I figured out, and I was able to remove all of these capacitors over this area just from beneath the cassette deck without taking the board. But it's this section here, this corner, approximately where you see now my finger going, all that area, there is plastic beneath, so it was impossible to remove the capacitors without removing the board. That was the only reason that at the end I had to remove the board. Otherwise I would have been able to do almost everything. There are about 55 capacitors, so you will be busy with this one. And with these I will probably do a final video with the case completely closed.